First of all, artificial is a natural fit for AI in science due to what we add in the data and deployment space. So anyone that's tried to incorporate AI into the workflows knows that AI models are not plug and play. You probably have to hire an entire data engineering team to be able to deploy these models, to integrate the data from them, and move data between other elements of your system. At Artificial, we like to say just add model, meaning we have a workflow engine in our platform that allows you to deploy models seamlessly and move data between the models and other elements of your system, whether it's scientific instruments, analytic systems, orchestrators, et cetera, in order to easily integrate AI insights into your workflow. What Artificial brings is we've already had to invent an extremely robust edge computing architecture just to be able to talk to scientific instruments on customer sites. And that same edge compute architecture allows us to deploy any sort of Python code, including Python code that incorporates PyTorch or Keras or TensorFlow and talks to either local GPU hardware on customer-owned GPU equipment, or can talk to GPUs hosted in the cloud either by Artificial ourselves or by the customer if they want to maintain complete control over the data.
At Artificial, our AI strategy is focused on 3 different levels. We have user level, operation or lab level, and then science level. To us, the science level is the most important level we want to focus on, which is focused on closed-loop labs or self-driving labs. So for this one, first, we'd like to integrate existing machine learning models. We have integrated the NVIDIA BioNeMo models very successfully, and then we include both discriminative models and generative models into our workflow. And the second category inside of this closed-loop lab is visualization. And then on top of that, we'd like to have add-on values. So we work with University of Toronto and NIST to make this happen. We're not only just integrating models, but also we evaluate the model trustworthiness.
Artificial is partnering with the Acceleration Consortium at the University of Toronto, which is the global leader in what's known as the self-driving lab, meaning a laboratory that performs wet lab science, but has experiments suggested and designed purely by AI models. So you can have a closed loop laboratory where experimental results are incorporated by AI models, new experiments are designed and then performed by automated equipment. And Artificial is such a natural fit for that because we provide the digital glue between the models and the automated equipment and any on-premise scheduling software that the customer may have in order to close the loop and truly realize the just add model vision that Artificial has.
When you have a model from this pipeline, we want to know if the model is trustworthy or not, or if the model is not good enough, which means you may have better drug molecules you're missing or some other candidates you want to catch, and then our capability is able to do that, and we can suggest new experiments or new molecules. So this is a science level, and then let's talk about the user level. On the user level, we'd like to develop a co-pilot. Now this is in development, and we're going to release this co-pilot in our first half year, 2025. We'd like to develop our co-pilot studio. So we're building our large language model-based RAG system that looks up user manuals for our customers when there's an error in the system. So instead of our customers looking at the manuals manually, they can actually use our RAG system and be able to get the rankings and also suggestions of where the errors occur. Our operation or lab level, we're having this lab event optimizer, which is an AI optimizer for events, scheduler, and Gantt chart. Customers need us because we have this capability of integrating these AI models. So there are pharma companies, biotech companies that are really good at science, but also the model companies are really good at modeling. I'd like to think that we want to keep companies doing what they're good at And what we are good at is doing our workflow integration and integrating not only just machine learning models, but also dealing with data silos in the lab environment. So when we talk about lab experiments, there are different data silos, and it's hard to get data off the instruments, it's hard to get data off the results, etc. So we are capable of doing all these integrations into one workflow that can really enable our customers for their closed-loop labs or self-driving labs. When we talk about closed-loop labs, we're talking about having automation, robotics, and AI in the loop for our experiments. So if you look at this diagram we have, usually we start with experimental parameters. So those parameters are the parameters that are needed to run experiments. And using artificial, we can get data off the instruments. So we're very good at doing the data management for you. Now, when you talk about traditional labs, this is covered in the gray area. When we talk about closed-loop labs, machine learning is in the loop. AI is in the loop. What the machine learning algorithms are doing is they are introducing or suggesting new parameters that are used for next round experiments. So if you look at this diagram, our machine learning methods suggest new parameters, and those parameters are used for next round experiments. We keep this loop going until certain properties are met. For instance, certain drug molecules are found based on certain properties. At Artificial, for our closed-loop lab development, first, we integrate existing machine learning models. If you look at this diagram, where we demonstrated our capability of machine learning model integration by working with NVIDIA BioNeMo, we're able to develop a virtual screening proof of concept to demonstrate that. Not only just that, we have add-on values. Our add-on values is developed based on our collaboration with University of Toronto and NIST. This is academic research, and we're looking at trustworthiness evaluation. After we evaluate the model trustworthiness, if the model is not trustworthy enough, then our algorithms can suggest better parameters. So in drug development, we look at the molecules suggested by the AI algorithms, and if new molecules are suggested by our add-on values, what that means is you can actually find better drug molecules. So that's extremely useful. And another value we have is visualization. So our visualization tools can be used for drug companies to look at insights from the machine learning models.
So a natural partner for Artificial is NVIDIA. And of course, NVIDIA provides the GPU hardware necessary to run these modern large models. But they also provide the BioNeMo framework, which is a suite of pre-trained bioscience AI models that are ready to incorporate into your workflow. Deployment and data movement are not plug and play, and that's where the Artificial platform comes in. So since NVIDIA provides the hardware and the models, and we provide the orchestration, the data integration, and the deployment framework, that truly does make these models plug and play for our scientific customers. So together with NVIDIA, Artificial has co-published an article on a proof of concept for discovery of novel COVID therapies. And in this proof of concept, we use the Artificial platform to stitch together 4 different NVIDIA BioNeMo models into a workflow that includes digitally folding a protein, digitally docking a therapeutic to that protein, and evaluating the efficacy of it. All in a closed loop, all purely in the digital domain. And the idea is that performing workflows purely in the digital domain allows you to vastly expand the number of candidate molecules you can examine before you use expensive wet lab resources, and thereby reduce the time and cost to go from inception of a molecule to clinical trials.